Okay, so for 4a, we have to show that dy over dx equals 1 minus 2xy over x squared plus y. So first you take the original equation, which is 2x minus y squared equals 2x squared y plus 10. So next you take the derivative, which is 2, and it's dx over dx, so it cancels out, so it's just 2. And then minus 2y dy over dx, which equals 4. Over here you use chain rule, which is 4xy plus 2x squared dy over dx. So next, you have to move dy over dx to one side. So you subtract 2x squared from the right side, and you subtract 2 from the left side. So you end up with negative 2x squared dy over dx minus 2y dy over dx, which equals 4x y minus 2. Next, you just want to divide by negative 2x squared minus 2y to get dy over dx by itself, and you do that to both sides, and you get dy over dx equals 4xy minus 2 over negative 2x squared minus 2y, and then that simplifies when you divide, because you have 2's in common. It simplifies to 1 minus 2xy over x squared plus y, which is what it is asking you to find, and that's your answer.
Okay, so we have to find the line tangent to the curve at point negative 2, 1. So we plug in 1 minus 2x y over x squared plus y. And the point is negative 2, 1. So we plug in this point into the equation. So dy over dx equals 1 minus 2 parentheses negative 2 over parentheses 1 over negative 2 squared plus 1, which equals to 5 over 5, which is 1. So the slope is m equals 1. Then you got to put it into point slope form, which is y minus y1 equals m parentheses x minus x1. So point slope form would be y minus 1 equals 1x plus 2. And that's the answer for B.
Okay, so for part C, we're going to start off with the equation we have in A. So 1 minus 2xy over x squared plus y. And then we're going to set that equal to k over 0, because in the problem it asks for a curve with a line that touches vertically. So when you think of a slope that's vertical, it's undefined, so anything undefined is over 0. So in order to get k alone, or let's get rid of this fraction here first, so we're going to multiply this by x squared plus y. X squared plus y on both sides. So then that's going to equal 1 minus 2xy equals k over 0 x squared plus y. And then to get rid of the 0, you're going to do the same thing but multiply by 0. So anything multiplied by 0 equals 0, so 0 equals k times x squared plus y. And then you're going to divide by k to get x squared plus y. So 0 equals x squared plus y. And then since you're solving for the y part, you're going to get y on one side, so you're going to end up with y equals negative x squared. So that's going to be your y, and you're going to plug that back into the original equation. So when we get back to the original equation, it's going to be 2x minus y squared equals 2x squared y plus 10. Yeah. So we're just going to plug in negative x squared for y. So it's going to be 2x minus x squared equals 2x squared times negative x squared plus 10. So 2x minus x to the fourth, because 2 times 2 is 4. And then same with this, you're just going to multiply it all out, so negative 2, because 2 times negative 1. And then x to the fourth plus 10. Oh. So basically we're just going to set this equal to 0, so we're going to move everything to the right side. So it's going to be 0 equals negative x fourth minus 2x plus 10. So after we get 0 equals negative x4 minus 2x plus 10, we're going to plug it into our calculators and find the x's. And when we do that, we end up with x equals 1.929 and negative 1.613. So after we find our x's, we're going to plug in back into the what we found for y. So we're going to do y equals, since we had y equals negative x squared, we're just going to plug in the x's we had. You have to do both of them. So you get y equals negative times negative 1.613 squared, and that gives us negative 2.602. So that's our y. So now that we have both x and y, our first coordinate is going to be negative 1.613 and negative 2.602. So since we need a second one, we're going to plug in the other x to the same equation. So it's going to be y equals negative 1.929 squared, and we get negative 3.721. So again, we have now 1.929 and negative 3.721. And that's all I was asking for C, the two coordinates.
For part D of question 4, it asks to find the second derivative of the equation 1 minus 2xy over x squared plus y, which is dy over dx. We'll have to use the quotient rule to solve this, but first the part 1 minus 2xy will require the product rule, and within the quotient rule. So in the quotient setup of everything over x squared plus y squared for g squared, or g of x squared, the 1 here will become 0, so we can leave that out. And this is where the product rule will come in. So for the derivative of f of x will be negative 2, and then y, because y is left alone here, plus the derivative of y and f unchanged, f of x unchanged. So negative 2x times d of y over d of x. D of x over d of x would go over here, but it was canceled out, so we don't need, or it cancels out, so we don't need to include that. From there is the, due to lack of space, I'll continue below, but this part is f prime in the first part, so it would be this negative 2y plus negative 2x dy over, that's a z, whatever, dx times x squared minus y to represent, okay, that's supposed to be a g. It represents g. And then for it will be subtracted by, there is not enough room on here, I will just continue underneath, 1 minus 2xy times 2x plus, I hit new page. Anyway, 2x plus d of y over d of x to finish off the quotient rule. Because this first part represents f of x, and now the rest of this equation, if you could read it, would represent the g of x for this equation. All over x squared plus y squared, which I'd include if it didn't make this work any more confusing. Now to begin simplifying, we will substitute in your dy over dx into this equation again. So, again, 2y plus negative 2x, and now it will be, I hit new page again, now it will be 1 minus 2xy, this is not fun to do without a stylus, x squared plus y, and then timed x squared plus y. So I will simplify the first part before moving on to the second part, simply because there's no room here. Anyway, as you can see, the x squared minus 7 on the denominator over here, and then the x squared plus y over here, that looks like a 7, will cancel out. So the simplified left-hand side of this equation is negative 2y minus 2x times 1 minus 2xy. I hit new page again. And then that's the first part. Now for the second part, it is also substituted in to make it 2x plus 1 minus 2xy over x squared plus y minus 4x squared. I'm going to write it over here because it is 1 and to avoid confusion. Minus 4x squared y minus 2x y. And this is also substituting in 1 minus 2x y over x squared plus y. So this is again the top part of the portion over x squared plus y squared again. And for one there's one more thing to simplify for this. To now start off, it would be negative 2y minus 2, and then from here it's FOILed out into this, 2x plus 4x squared y minus 2x plus 1 minus 2xy over x squared plus y. That was Mark in the video. If you hear him, don't blame me. And continuing it, because again I have no room, minus 4x squared y minus 2x y times 1 minus 2xy over x squared plus y. This is all over x squared plus y squared, which is the final answer for the second derivative of this problem. I apologize for the mess.